Hi, folks. Welcome back. And in preparation for our a better reverse pair problem using merge sort, what we would do is we'll first explain how to merge two arrays which are sorted basically in another sorted array basically. So the idea is, for example, you have two arrays here, int A 12, 32, 51, and here is even B, which is 131, 53. These are sorted, as you can see, and we would like to create another array C, which would be sorted, but using these elements basically. So how we create a sorted array using two sorted arrays? So let's implement that. So first thing, as you can see, is I allocated the memory for C using calloc. And as you know, calloc is very simple. It uses the size. It takes two arguments basically, the size and the size of each block of memory. So in this case, size A plus size B. Obviously, the C would be the sum of these two elements, size of A plus size of B. So sum of these the sizes of these two arrays, the sum of the sizes of these two arrays. So as you can see, is what I did here. I say size A is the array size A, size B is the array size B. And then we get size A plus size B, and comma size of, and then size of int is the size of each unit of memory. So we want size A plus size B. In malloc it would have been size A plus size B times size of int, but in calloc it takes two arguments, except it gives you zero initialized memory, so that is good. So now let's implement the algorithm print, and once print is done, we know our job would be done. So let's try to implement. So what would print's prototype look like? So first write what is the merge prototype will look like. So merge to int star A, you could say int star B, which is array A, array B. You know in C, pointers are just another way of saying array, or an array name basically boils down to a pointer. So it could have been also written int A as in pointer notation, in array notation, like this, but I chose to write it in pointer notation. So there you go. Now this int C, as you can see, the C's memory is allocated by the caller, not by the called. Otherwise, you will get into even more interesting C stuff, but we will not go there. Size A, comma, size B. And so first thing we do is we have to work with this on this algorithm using three local variables I, j, and k. So I is equal to 0. Why I, j, and k? So I would be for the bounds of C, and j and k would be for the bounds of A and B. So j is equal to 0 and k is equal to 0. Now, first thing is, when both j and k are within their own bounds. So basically, if j less than size A, and k less than size B, so the algorithm goes like, what we do is, when both j and k are within their respective array bounds, then we go element by element, and we see, like for example, if aj which is kind of saying the element of A is less than element of B. We take it from A basically. We say Ci equal to, so we basically pick from A. So Ai, sorry, Aj. So that is the important point. So I is the index for C and J is index for A and K is index for B. So you have to be consistent there. So here when we pick from there, after that we move to the next element from where we picked. So we picked from A. So that's why we have to say J plus plus. And then of course we have to make room for the next element to be put into C. So that's why we have to say I plus plus. So once that part is done, then right now it is not completely done, but basically this is the else case. So if Aj was less than, if when we started looking into A and then we looked at B and say whichever is less, so A was less, so we picked from A, but if not else, then we pick from B. So in that case we have to have Ci equal to B. So I think it would be B. Oh yeah, that's okay. So here otherwise we pick from Ci equal to Bk and K plus plus, and whichever from wherever we pick, we have to move to the next after we have picked from there. So that's why K plus plus and I plus plus as usual. So here this is the end of while, I think. Let's see. Yeah, it's the end of while. So now you see, if you come out of the if else, what could have happened? So if we came out of if else, so the condition was, and this is a logical end. So both A and B has to be true for while the condition within while to be true. So if we were inside the while, that means the condition that J is within its own limit and K is within its own limit. Jk is less than size B, both is true. But if we came out, it could be because J is moved past size A, or it could be that K would have moved past us. Definitely one of them have to move out of its respective bounds. So that is why we basically came out of that while. So let's see that. This is while, okay. So now if that's the case, then what do we need to check? Then we have to check if while J is less than size A. Then we just say Ci, same thing that we were doing in the if part, Ci equal to Aj, and J plus plus and I plus plus. Similarly, if while K less than size B, I mean we could have probably came out of it not because this was true, that J, so that we came out of this first while loop because the second part was still even though this became true that J was less than size A, but K went past size B. So that is why we probably came out. So in that case we'll hit the second while, but if not that, then we'll hit the third while. So if K, we came out because K was no longer less than size B, then so that means K is still less than size B. So that is why we'll hit the third while loop. So K less than size B, and if that is correct, then what happens? then Ci equal to Bk, right? Ci equal to Bk. And so we start then, just exhaust the one that we haven't yet exhausted. So this is what is going on basically in plain English language. So we are exhausting the one that is still uh, have more elements left. So k plus plus and I plus plus. So if you see, that's pretty much your algorithm. What you need to do is, I think we have made a mistake here, which is this while should have been finished here. So here you see that this while loop here is the first while loop where both j and k are within their respective arrays is basically finished there, and then this while loop says that if we came out of the one of them is no longer is still to be exhausted, basically, pretty much you could say that. So one of them is still to be exhausted, meaning that it hasn't finished its the its array's size yet. So that is why we have to now make sure that it does finish. So obviously, if it could be that one of them goes past its respective array, not both, because if both, okay, so it could be that j, can it be true that j is less than size a and k is less than size b? So suppose you take this particular case here. Let's add one more just for the heck of it. Let's add one more here, 91. So a is 4 and b is 3. So a is 4, size a is 4, size b is 3. So now you see what will happen. When we are in the first while loop, we will end up exhausting 3, k would be no longer. So when we see that k is no longer less than 3, we will basically come out of the first while loop. Actually, k would be, think about k is 3, right? So k will go up to 3 and will finish. So that's fine. So the j would still be 3. Then we while j less than size b and k less than size b. So k less than size b, but then k would be at this point equal to size b. And once that happens, we would exhaust k. That means first while loop will be false, and then we'll come here and then we'll go to the second while loop because j is still less than size a. So we'll pick the remaining element from j's, and then k would already been exhausted. So that way, this is the algorithm for merging two sorted arrays into the third array, sorted array. And let's see if it runs. So let's try to do that. So you can see that we started 12, 32, 51, 91 array A, 131, 53 array B, and then we got array C, which is 1, 12, okay, 1, 12, 31, 32, then 51, 53, and then 91. So you can see the C is also sorted, and this is pretty much, you could say, the what we would use when we do our reverse array using merge sort, where we can do it in one pass rather than a loop within a loop, and that will help us actually solve that problem and more efficiently. So I hope it was clear, and with this I would, in the next video we'll actually do the reverse pair using a variation, or pretty much the same thing, but there might be some different changes. For example, here we actually pass three arrays, but what if you pass only one array but give your three arguments to it? So you have like left, right, and then the middle is the mid. So suppose left and mid is sorted, and mid is right is sorted, mid plus one and right is sorted. So there will be some change to it, some little bit different inside the merge function, but basically the crux of the matter, this algorithm would remain here same. And that how to basically pick element in the right order so that the resulting array is also sorted. So with that, I'll leave you guys alone, and I'll see you next time. Until then, bye.